So in this case, P, Q, R, and S are points on the circumference of a circle with center O. POR, or simply PR, is the diameter of the circle, and angle QSO is equal to X. Angle OPS is equal to 3X. So the first question for us, which is for 2 marks, is to determine the size of angle SQR in terms of X. So in order for us to find the size of angle SQR, we realize that this arc, RS, it subtends angle OPS, and the very same arc subtends angle SQR. And we know that angles subtended by the same arc at the circumference of a circle, they are equal to each other because they are angles in the same segment. So that's what you tell them. Over and out. Then the next question says, for 3 marks, determine the size of angle PQS, this one. And the mark allocation never lies. It tells you that you have to do something first before going to angle PQS. Well, you realize that PR is the diameter of the circle, and the angle subtended by the diameter at the circumference is 90 degrees. So that's where you begin by telling them that the whole of angle P is actually 90 degrees because it's an angle in a semicircle. Awesome. So we know that the size of this angle is 3x, and we know that the whole of this angle is 90 degrees. So if you make this one the subject of the formula, you are just going to say, well, PQS is equal to 90 degrees minus 3x over and out. The next question says, determine the size of angle PQS. Sorry, it's angle PSQ. Sorry about that. PSQ. So this angle. And it's also for 3 marks. So it tells you that you have to do something first. So here you observe that OP is the radius of a circle, and OS is also the radius of a circle. So since the radii are equal to each other, it means this is an isosceles triangle. And we know that the angles opposite equal sides, or the base angles, if you like, we know that they are equal. So that's where we must begin for this one. So we begin by saying angle OPS is equal to angle OSP, and both of them are just 3x because they are angles opposite equal sides. So we know that the whole of this angle is just 3x, right? But if we know that the whole of this is 3x, and we know that this one is x, then it stands to reason that PSQ is equal to 2x. Do you see that? So it's the same way as we dealt with the previous one. So we can conclude and say, therefore, angle PSQ will just be equal to 2x. And then the next question for 2 marks, this is what it's asking from us. It says determine the size of angle PRQ. So which one is that? PRQ, this angle. So it's only for 2 marks. It means we can go straight to it. Well, here we realize that this angle is actually equal to this angle. Why? Well, that's because they are subtended by the chord PQ. So this is what we see, and this is also what we see. You can say it's the chord PQ, or you can say it's the arc PQ. It's up to you what you say. So we know that they are angles in the same segment. So we say, okay, angle PRQ is equal to angle PSQ, and both of them are equal to 2x because they are angles in the same segment. Or you can just say seg, that's fine. Awesome. Now the last question for 2 marks, it says determine the size of angle QPR. So this is Q, this is P, and this is R. So we have to find the size of this angle. So for this one, we can simply use the sum of interior angles of a triangle, because we know that the size of this one is 2x and the size of this one is 90 degrees. So we can say, if we take QPR, we add it to PQR, we also add it to QRP or PRQ, this sum will be equal to 180 degrees because it's the sum of interior angles of a triangle. So we are looking for QPR, but we know that PQR is 90 degrees. And we also know that PRQ is 2x. Then we take everything to the right-hand side. So it becomes negative. So 180 degrees minus 90 degrees, it's 90 degrees. And we still have our 2x there. So that's the size of angle QPR. So this should be the end of this video. Thank you so much for watching.